The 20th century opened the gates to an era of modern science, where each fragment of fossil bone was not merely the remnants of time, but machines powerful enough to shake the very foundations of academia. But what if the past was never fixed at all, but instead always ready to overturn everything we thought was certain? If fossils can continuously rewrite the past, then might they also hold clues to the future of our own species? How did these creatures survive through upheaval? What strategies allowed them to prolong their existence in a world full of instability? And most importantly of all, hidden in the secrets of stone and bone, can humanity today discover ways to better understand life itself? Let us revisit the most earth-shaking paleontological discoveries of the 20th century in search of answers for the future. Part 1. When giant monsters became reality. We believed that we had understood the rulers of the past, but in reality, we had only seen a shadow. The first fossils discovered carved into our minds the image of a king, a nightmare, but it would take an entire century before we truly comprehended its power. The Ageless King, T-Rex, 1902. In the early days of the 20th century, a famous adventurer and fossil collector for the American Museum of Natural History, Barnum Brown, traveled to Hell Creek, Montana. He was not a scientist confined to a laboratory, but an adventurer, a man who lived for the thrill of fossil hunting. And in 1902, he discovered something that would forever change how we understand the past. Then, in 1908, at another site, Big Dry Creek, Brown made an even more spectacular find, a nearly complete skeleton of T-Rex, including a perfect skull. To free the massive specimen from the ground, the expedition even had to use dynamite to break the surrounding rock. Catalogued as AMNH 5027, this skeleton, now displayed at the American Museum of Natural History, became the enduring symbol of dinosaurs as a whole. From the very beginning, Tyrannosaurus rex was no ordinary dinosaur. It quickly transcended the boundaries of science to become a cultural icon. With its upright posture, the public regarded it as a monster with an enviable stance. Its popularity grew so vast that the word Tyrannosaurus was used in publications twice as often as any other dinosaur name, and it had already secured its first starring role in film as early as the 1910s. This is a fascinating paradox. T-Rex was not the only dinosaur discovered at the time, but it became the sovereign of human imagination. This was not only because of its size, but also because of the timing of its discovery. The birth of cinema and mass culture transformed it into a franchise fossil. The logo of the blockbuster Jurassic Park was inspired directly by the skeleton housed at the AMNH, reinforcing its status as a symbol of antiquity and destructive power. This image became so deeply imprinted into our minds that we came to accept even a false scientific fact. T-Rex never lived in the Jurassic, but we still call the film Jurassic Park. The missing predator, Spinosaurus, 1912. If T-Rex reshaped culture, then Spinosaurus revealed the fragility of knowledge. In 1912, only 10 years after T-Rex was unearthed, German paleontologist Ernst Stromer discovered a massive skeleton in Egypt. With an impressive sail of bone rising from its back and a length rivaling T-Rex, this creature was proclaimed the largest carnivorous dinosaur ever to live. But then tragedy struck. On the night of April 24-25, 1944, Allied bombing during World War II destroyed Munich's Paleontologisches Museum. Along with many other invaluable specimens, Stromer's unique Spinosaurus fossil was completely obliterated. All that remained were detailed notes, drawings, and a void in knowledge that lasted 70 years. This event became a powerful metaphor for how human history can erase Earth's history. That void forced paleontologists to rely on Stromer's sketches, reconstructing Spinosaurus as an ordinary land-based theropod. For decades, the world knew Spinosaurus only as a name in textbooks, until fragments began to re-emerge. In the 2000s, new discoveries from Morocco's Sahara Desert and from an Italian museum collection resurrected the legend of Spinosaurus. For the first time, scientists could create a complete digital reconstruction, revealing an utterly unexpected creature. It had a long, narrow, crocodile-like snout, with sharp, conical teeth perfect for catching slippery fish. These new findings led to a revolutionary hypothesis. Spinosaurus was a semi-aquatic predator, living primarily in the immense river systems of prehistory. This hypothesis was reinforced by later discoveries, including a paddle-like tail and evidence of dense bones thought to help it sink in water while hunting. For a time, Spinosaurus was believed to be a true aquatic predator. But then, in 2022, a new study by paleontologists at the University of Chicago reignited fierce debate. Based on updated virtual reconstructions, they argued that Spinosaurus could not have been fully aquatic. The simulations showed that the thrust of Spinosaurus's tail was far less effective than that of a crocodile, and with its immense body mass, it would have been too rigid to propel itself efficiently in water. Calculations revealed that Spinosaurus would have been too buoyant to submerge fully, requiring 15 to 25 times the estimated thrust its tail could generate. The large sail on its back would also have made it an awkward swimmer. The evidence of dense bones might simply have been to support its enormous weight on land, similar to hippos. Fossils found in inland river basins, not only along coasts, suggest it was more likely an ambush predator in shallow waters, rather than a fully aquatic creature. The story of Spinosaurus is a perfect metaphor for the ever-changing nature of science. From a lost skeleton, it was reborn as a semi-aquatic king, and then it became the center of a debate more complex than ever. Scientists do not declare, "We know everything." Instead, they say, "We are still debating." Part 2. Truth from Fossils. When dinosaurs grew feathers. For nearly a century, we believed dinosaurs were bare, scaly reptiles. But in a distant land, a tiny discovery overturned that entire perception, and once again, the past came alive with colors we never imagined. The feather that shook the world, Sinosauropteryx, 1996. In 1996, a Chinese farmer and fossil hunter, Li Yuman, found a small but powerful specimen, the fossil of Sinosauropteryx. When unveiled, it provoked fierce debate. Were the delicate filaments preserved around the skeleton primitive feathers, or simply fossilized collagen fibers? Subsequent studies proved they were real feathers, containing pigment cells. For the first time, scientists could identify the actual color of a dinosaur. Sinosauropteryx was not a naked reptile. It wore a coat of reddish-brown feathers with alternating light and dark stripes on its tail, possibly for camouflage. This discovery was not just a curiosity. It was the first and most crucial physical evidence, providing a solid bridge, proving the direct evolutionary relationship between dinosaurs and modern birds. It replaced the outdated image of dull, scaly monsters with vibrant bird-like beings. It opened a new era for paleontology, forcing us to reconstruct the entire dinosaur universe. The discovery of Sinosauropteryx was only the beginning. Chinese paleontology revealed a universe teeming with feathered dinosaurs. We found Caudipteryx, with bird-like feathers but wings too short for flight, showing that feathers had evolved for insulation long before flight. And then came Microraptor. Found in great numbers, it was one of the most common dromaeosaurid fossils, with feathers on both arms and legs, forming a four-winged design. Scientists debated its ability. Some believed it could only glide between trees like a flying squirrel, while others thought it was capable of controlled flight. This wave of discoveries completely dismantled the old vision of dinosaurs as naked lizards. We not only found feathers, but many types of feathers, from simple filaments on Sinosauropteryx to complex structures on Microraptor. This showed dinosaurs experimented with many methods of flight, and that evolution from dinosaur to bird was not a simple straight line, but a process full of trials and diversity. Part 3. The Stumbles of History. When rulers were not perfect, science is not a perfect straight line. It is full of wrong turns, fiery debates, and even shameful failures. But those very mistakes became the most powerful forces driving us to learn and move forward. The Bone Wars and the Misplaced Head. At the end of the 19th century, American paleontology was dominated by a fierce rivalry between Edward Drinker Cope and Othniel Charles Marsh. Known as the Bone Wars, their competition led to unethical acts, bribery, theft, and even the destruction of fossils to outdo each other. In his rush to publish, Cope made a disastrous mistake with the fossil of Elasmosaurus. With a neck twice as long as the rest of its body, this marine reptile had a bizarre structure, and Cope mistakenly placed its head on the tail end. Marsh wasted no time in ridiculing him, turning the blunder into one of paleontology's most infamous stories. This was a vivid example of the clash between motive and outcome. Though driven by rivalry and even bad science, the Bone Wars produced a golden era of American paleontology, with over 140 new dinosaur species discovered. Cope's error, though shameful, became a costly lesson in meticulousness and objectivity. It showed that even mistakes can unexpectedly push progress forward, and when acknowledged, they can become powerful motivators for improvement. The mysterious spike. Iguanodon. Iguanodon was among the first dinosaurs ever named. When its fragmentary bones were found, a strange conical spike baffled scientists. Assuming dinosaurs were simply giant lizards, they placed the spike on its nose like the horn of a modern rhinoceros iguana. Not until 1878, when 24 nearly complete iguanodon skeletons were found in a Belgian coal mine, did the truth emerge. The horn was actually a sharp thumb spike. Though its placement was corrected, the question of its true function remains a mystery. Was it for defense? Attacking predators? Cracking seeds? Theories remain speculation, without conclusive evidence. The story of the iguanodon spike shows that correcting a mistake does not mean we fully understand the truth. It is similar to the false thumb of the red panda or the giant panda, strange adaptations in modern animals whose exact origins and functions remain unclear. To solve such mysteries, we must move beyond conventional thinking and try to think like a dinosaur. Part 4. When Time Restored the Truth, the Return of Brontosaurus. Some names were erased from science, deemed mistakes, but sometimes with new tools and knowledge, history can be rewritten, and a legend thought dead can be revived. The fall from grace of a legend. For generations, Brontosaurus, the thunder lizard, was one of the most famous long-necked dinosaurs, a cultural icon embedded in memory. The name was given by Othniel Charles Marsh in 1879. But in 1903, paleontologist Elmer Riggs declared that Brontosaurus was not distinct enough from Apatosaurus to warrant a separate genus. Since Apatosaurus was named earlier, Brontosaurus was deemed a scientific mistake and discarded. For nearly 100 years, the name survived only in storybooks and popular culture, while museums and academia officially used Apatosaurus, the return of the thunder lizard. But in science, nothing is permanent. In 2015, a groundbreaking study led by Emmanuel Schopp, a paleontologist at the University of Lisbon, unexpectedly revived the legend. Schopp had no intention of restoring Brontosaurus, but the data led him there. The cervical vertebrae of Brontosaurus were described as extremely robust and heavy, unlike the lighter vertebrae of Apatosaurus. A depression on the backside of the scapula appeared in Brontosaurus but not in Apatosaurus. His study analyzed 81 skeletons and 477 anatomical traits, producing the most comprehensive dataset ever on sauropods. The results showed Brontosaurus and Apatosaurus were distinct enough to be considered separate genera. Based on undeniable quantitative evidence, the name Brontosaurus was officially resurrected in science. The story of Brontosaurus demonstrates the power of data and modern analysis. It shows that even a name forgotten for a century can return if the evidence is strong. Paleontology is evolving from a science of observation to one of data, where hypotheses can be retested with precision and past mistakes corrected. Conclusion: the 20th century witnessed paleontological discoveries that overturned all of science. We once thought dinosaurs were sluggish lizards until T-Rex. We once believed they were naked and scaly until feathers were found. We once laughed at reconstruction errors, only to learn mistakes drive progress. And we once declared a name dead until modern science resurrected it. Paleontology's history is a series of unexpected paradoxes. Fossils do not only recount the past of prehistoric life, they remind us of ourselves. Knowledge is not a destination, but an endless journey. And even in what we believe we know, Earth still hides secrets, waiting to astonish us again. Looking back at the 20th century, we see that every fossil was not just dry bone, but a living record of Earth. From T-Rex showing that power is not eternal, to Spinosaurus proving knowledge can be lost then reborn, to the feather of Sinosauropteryx revealing the bridge to modern birds, all answered the great questions we ask. They survived upheaval by adapting. They extended life by changing form, hunting styles, even biological mechanisms. And the message for us today is clear. The secret of endurance lies not in absolute power, but in the ability to listen and adapt to the world around us. So when we look at fossils, we do not only see the past, we see a mirror of the future, a future where our survival may depend on whether we are willing to learn that timeless lesson. And you? What do you think humanity should learn most from these ancient creatures? Strength, adaptability, or evolution's creativity? Share your thoughts below, and don't forget to like and subscribe so together we can continue the journey of uncovering Earth's hidden secrets.